You are watching the Target 6.1 retest video. In this video, you are going to take some notes on some of the problems that we do in the white packet that you should have picked up from your teacher or printed off from the server. We're going to start out with graphing, and then we're going to write some graphs, both square root and cube root functions. So a little bit of notes in advance. These are to help you find out what kind of patterns you can use in order to graph these functions. So if we take a look at the square root of x, the square root of x works only with positive numbers, first of all, but then if we can put in numbers for x that actually make perfect square roots, and these things are called perfect squares. So 0 works because the square root of 0 is 0, and 1 works because the square root of 1 is 1, and 4 works because the square root of 4 is 2. Now, that doesn't mean that there aren't points where 2 and 3 are. They're just decimals, and they're harder to graph. So why would we? 9, square root of 9 is 3. Again, 5, 6, 7, and 8 work also. You just get decimals somewhere between 2 and 3. 16 is another one. 25, 36, 49, 64. And the list goes on forever. So graphing that one, 0, 0, 1, 1, 4 and 2, and 9 and 3. Those are the ones that fit. And 0 is a starting point because we can't go into the negatives. So what I would like you to see is that because of the perfect squares, it's over 1 and up 1, and then 4 is the next perfect square, and you go up 2. And then starting back from the vertex, 9 is a perfect square, and you go up 3. If there was another place, it would be going over 16 spots, and you would go up 4. So that's the way that the square root works. And we're going to use that 1, 4, 9 pattern when we graph these actual functions. So let's look at the cube root. Now the cube root is special because it does work with negatives. So we'll start out in the middle. We'll use green. But the cube root of 0 is 0. Now instead of perfect squares, we're going to use perfect cubes. So the cube root of 1 is 1. The cube root of 8 is 2. Another way to think of that is 2 cubed is 8. But it also works with the negatives. The cube root of negative 1 is negative 1. And the cube root of negative 8 is negative 2. So this graph looks like this. I'll make the dots a little bigger. So here's the next one, 8 and 2, and then negative 1, negative 1, and negative 8, negative 2. So this graph looks like this. The pattern that I would like you to see for this is, let's get rid of this other pattern here first. The pattern that I'd like you to see for this is that we go over 1 and up 1. And starting from here, that next perfect cube was 8 and up 2. And notice that the cube roots also have 2 legs. So left 1, down 1, and then left 8 spots, down 1. So the perfect cubes and the perfect squares are really integral in how you are graphing these functions. So let's look at some actual problems that are on your sheet. This first one is number 1, and then we'll do number 8. This one is a square root. This one is a cube root. And the square root, we had talked about the perfect squares. And the cube root, we talked about the perfect cubes. Remembering that negative 1 and negative 8 are also perfect cubes. So the process that both of these are going to start with is finding the starting point. And the second step that we're going to use is we're going to use the pattern of the perfect squares or perfect cubes to do the rest of the points. And we'll talk about domain and range when we get there. So the starting point for all of these, and you probably recognize this from parabolas, has to do with those two numbers. This one is going to be the opposite. This one is going to be the same. And if you remember, that stems from this function. And for the cube root, it looks like this. And notice that both of the h's are minus h, which means it's opposite. And then both the k's are plus k, which means it's the same. There's also a number a out in front. We'll talk about that in a second. So for the square root then, the starting point is going to be positive 3, it's the opposite, and then negative 5, it's the same. So positive 3, negative 5 is right here. And then if we use the pattern, 1, 4, 9, along with this number here, we can find the rest of the points. So that number is called the vertical stretch. And that number stretches the graph up or down. So positive 3, it's going to stretch it 3 spots up before we go over 1. And then 4 from the starting point, 1, 2, 3, 4, and then 3 and 3 more. So that vertical stretch tells you how far to go up in between the pattern points. There is our graph. And the same thing happens for the cube root, except the pattern of 1 and 8, because the perfect cubes are 1 and 8. So the opposite of negative 2 is 2. Opposite of positive 1, or same as positive 1 is 1. So 2, 1 is our starting point. Now we use our pattern along with the vertical stretch. Our vertical stretch in this case is down 1 because it's a negative 1. So 1, down 1, and then from the starting point we're going to go 8 spots and then down another 1. So we have this, but cube roots have a second tail. So remember, negative 1, negative 8 takes us in the other direction. So negative 1, and then up 1, and then 8 from the starting point, and then up another 1. There you have it. So there are the two graphs. If we talk about domain and range, for cube root, it's kind of easy because you can take the cube root of everything. So the domain is all real numbers. The range is also all real numbers. Every one of these has a y-intercept. They all have an x-intercept because all the points are fair game. Not so much true with the square roots. Square roots have the starting point, and that affects our domain and range. So the domain has to do with that 3 that we got from the starting point, and that everything is to the right of 3, so it must be greater than or equal to. And in this case, the y's have to do with the y's, that's a negative 5, and everything is above the y, so it's greater than or equal to. Now, if our vertical stretch was negative, it would be going down. Therefore, the domain would be less than or equal to. All right, let's go ahead and review that if you want. Rewind it. Go see your teacher before or after school if you need any more help. In 18 or 19, we're going to look at the functions and decide what the domain and range is right from the beginning without graphing it, and then also talk about the shifts. So right away we see cube root, and we know right away domain and range are all real numbers for cube roots. Okay, this shift is left 4, and this shift is the same, so it's up 1. Right? Domain and range for square roots is a little different. So let's talk about the shifts first. This one is left 1. Remember, it's the opposite of that. And then the same as this, so it's down 4. So our starting point is 1, negative 1, and negative 4, which means our domain, x, has to do with the x number, greater than or equal to negative 1. And our range, since our vertical stretch is going up, our range is y is greater than or equal to negative 4. That's the y number. So the x goes with the x number, the y goes with the y number. X is always going to be greater than or equal to, in our case, in this class, as in y is dependent on whether we are graphing up or down. So the last piece then, let's look at writing equations, knowing that we're going to write them in either this form or this form. This is going to be a cube root. This one is going to be a square root. Cube root because it has both legs, goes to the left and goes to the right. Square root because it has a starting point and only goes in one direction. So let's get that starting point. For this one, it's negative 2 and negative 3. And the vertical stretch looks like it's going up before it goes right. So it's up 2, so it's positive 2. So that means our function is 2, and then it's the cubed root of the opposite of the x and the same as the y. So we plugged in this from the stretch, opposite of our starting point x for that, and the same as our starting point x, y for that. So then for this one, the starting point is 1, 5. It's a square root. It looks like it's going down 3 before it goes right 1. So our function is negative 3 square root, it's the opposite, and then the same. So there you go. You can rewind and watch any of those parts of those problems to maybe review it or study it before you take the tests. Maybe you need some more help for practice. See your teacher before or after school to get that help.